Here's the engine start system for the Boeing 737-400. Engine 1 is on the left, viewed from the flight deck. Engine 2 is on the right. Currently, both engines' igniters are off. In the middle, there's a switch to select left or right ignition. Start operation requires pressurized air and electrical power. Air from the bleed air system powers the starter motor. The APU, auxiliary power unit, an external ground cart, or the other operating engine, if one's already started, provides the bleed air source. In the ground position, the engine start switch uses DC power from the battery to close the engine bleed air valve and open the start valve to allow air pressure to rotate the starter. The starter rotates the N2 compressor through the accessory drive gear system. When the engine accelerates to the recommended value, 25%, or max motoring, which means it's not increasing anymore, moving the engine start lever to the idle position opens fuel valves and causes the main engine control to supply fuel to the combustor, where the fuel ignites. At starter cutout speed, about 46% N2, power is removed from the engine start switch. The engine start switch returns to off. The engine bleed air valve returns to the selected position and the start valve closes. Here's some of the dials that we'll be looking at during an engine start, which feature N2, N1 and exhaust gas temperatures. Abort the start. Well, if the N1 spool doesn't start turning before the start lever is raised to idle, no oil pressure is indicated by the time the engine is stable, no exhaust gas temperature within 10 seconds of start lever being raised to idle, no increase or a very slow increase in N1 or N2 after an exhaust gas temperature indication. And lastly, exhaust gas temperature is rapidly approaching or exceeding 725 degrees Celsius.